Hi, chemistry students. It's time to learn naming formulas. I know that you already know how to write binary ionic compounds, even though some of you still need some more work on it. But now we're going to learn how to write formulas and name compounds using the chart on page 255. These are transition metals that sometimes have more than one charge. For example, we can use Fe2 plus or Fe3 plus. How will we know, you ask? Well, they'll either tell us or we can discover it from using the formula they give us. Here's an example. They want us to write the formula for copper 1 sulfide. The Roman numeral 1 tells us that it is copper 1 plus. So we write copper 1 plus, sulfur 2 minus, crisscross just the numbers, and we end up with Cu2S. Here's another example. They want us to write iron 3 sulfide. You write Fe3 plus S2 minus. Crisscross the numbers, and you end up with a formula Fe2S3. Here's another one. Copper 1 bromide. So copper has +1 charge, bromine has -1. Crisscross the numbers, you end up with CuBr. If you notice, here is a 1, here is a 3, here is a 1. That's where you're going to go look to figure out which of the cations you are going to use. Try writing these. I'll give you a few minutes, and then I will do them. We'll come back to the answers in a few moments. You can pause this if you need more time. All right, so let's say that we're given a formula and we're told to name the compound, Fe2S3. You know that the subscript on sulfur was the crisscross number from Fe, so send it back as a charge of 3 plus. Write Fe3 plus S2 minus. This means iron 3 sulfide. Try this one. Move the 2 back up here. So this tells you, and this is always going to be a positive because we're moving it to the cation. This tells you that Sn has a charge of 2 plus, and sulfur has a charge of 1 minus. But now, if you're really with it, you will realize, no it doesn't. Sulfur has a -2 charge. They reduced the numbers in the bottom up here. So now, because we know sulfur has a 2 charge, we have to multiply each of these by 2. So that means it should be Sn4 plus S2 minus. So this compound was tin 4 sulfide. Here's another example. They give us Mn3 and 4. Well, the 4 needs to go up here. So here I've moved the 4 up and the 3 up. That tells me that this is manganese 4 nitride. Now, once you get the hang of this, you don't need to go through the effort of crisscrossing these. You can just look at this and go, oh, Mn3N4, manganese 4 nitride. If you just reverse the process and still crisscross, it will use the first symbol name the same, add the Roman numerals, and then add "ide" at the end to name the compound. So let's try this one. Oh, I'm looking here. I see a 3 over here. So that tells me this is iron, just use the regular name, 3 chloride. Remember, everyone ends in an "ide." Now, try these. Okay, now I'm going to go back and give you the answers to the other ones. We have iron 3 nitride. There's no spaces left in between here, just writing all together. So we have iron 3 plus N 3 minus. So our answer is FeN. The next one was tin 4 oxide. SN 4 plus. Oxide is oxygen 2 minus. Crisscross them. This goes SN2O4. But because these are multiples, we reduce it to SNO2. And the last one was cobalt 2 nitride. Cobalt 2 nitride. Cobalt is CO. This tells us it's a 2 plus charge. Nitride is a 3 minus. So cross the numbers. The 3 goes down here. The 2 goes over here. So it's CO3N2. Now, the ones where you have to write copper, CuF. Well, there's a 1 down here because there's no number written. So that tells me there's a 1 up here. So it's copper, Roman numeral 1, fluoride. The next one is Fe3O2. The 2 tells me it came from up here, so that is iron Roman numeral 2, oxide. What do these numbers here tell me? Well, this tells me that in order to make this compound, I need 3 batches of iron and 2 batches of oxygen in order for them to mix together and make that compound. You just don't read all the numbers. All right, once again, there's nothing written down here, so we know it's a 1. So it's copper 1 nitride. All right, just a minute, I gotta turn my page. All right, so the next thing I want you to do is make a chart. And on this chart, you're going to have these compounds. And I'm going to go to a different page to show you exactly what I want you to do. I'm going to turn the page here so I can see both of them. I want you to write formula at the top. And then the positive ion, which is a cation. And we'll put a positive up here so you know that. And then the negative, the anion, which is negative. And then you're going to name it. So, the first one, we're going to write Fe2S3. Cation always comes first. Cation always comes first. Cation comes first. So the cation is Fe3+. The anion is S2-. Excuse me. So we're going to write the name. Iron (3) sulfide. So I guess I have 9 of them written down here for you. This one is Al, aluminum. So, after you get this done, I want you to go into your cupboard or pantry or whatever, wherever you got some food. Pick 3 packages of something, all different. And I want you to go to the ingredients list. And I want you to look for chemicals on your ingredients list. So, I have a breakfast burrito here. And I don't want you to write down things like eggs, non-fat milk, butter. I want you to look for something that would have a cation and an anion. And believe it or not, oh, I did find one. I have calcium chloride. So write down calcium chloride. And you can use this chart, well, make your own chart. Calcium chloride. I want you to write down the anion, so it's calcium 2 plus. The cation, the anion. And then I want you to try and write the formula. Now, some of them are going to be really crazy, and you might only get the cation. That's okay. Some of those are like sodium poly blah 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 nate. I know you're not going to know the anion, but what I want you to realize is how many binary compounds there are in your food. Hopefully, you can get more than 3. I would like you to get at least 7 compounds out of food wrappers. So if you need more than 3 things of food, get more than 3 things of food. You need 7 wrappers, 7 compounds. So you are going to do the list of compounds into a chart. That's number 1. And number 2, compounds from food wrappers. Hope you enjoyed Monday's lesson. Bye.